This is the solution for homework 3, question 25. The question reads, a certain brand of automobile tire has a mean lifespan of 39,000 miles and a standard deviation of 2,350 miles. Assume that the lifespans of the tires have a bell-shaped distribution. The lifespan of 3 randomly selected tires are 34,000 miles, 36,000 miles, and 32,000 miles, and we want to find the z-score that corresponds to each of these specific lifespans. So we start by reminding ourselves that the z-score is calculated by taking a particular data value, subtracting the mean, and dividing by the standard deviation. And what this will do is tell us how many standard deviations the particular value x is away from the mean. So here our mean is 39,000 miles, our standard deviation is 2,350 miles. The first data value we're interested in calculating a z-score is 34,000 miles. So that's our x. And to calculate our z-score, we take our x, 34,000 miles, subtract our mean of 39,000 miles, divide by the standard deviation, 2,350 miles, and we get a z-score of minus 2.13. So I'll put that in here, minus 2.13. Fantastic. For 36,000 miles, now that's my new data value that I'm interested in, so that's my x. I take my x, 36,000, subtract the mean, and divide by the standard deviation to get a z-score of minus 1.28. So I'll enter that here. Excellent. And then for the third lifespan, 32,000 miles, that's my particular value x, so I take 32,000 miles, subtract off the mean, divide by the standard deviation, and I get a z-score of negative 2.98. And I enter that. Good job. Okay. According to the z-scores, would the lifespans of any of these tires be considered unusual? Now remember, unusual values are those that are more than 2 standard deviations away from the mean. So since this x is 34,000 miles, has a z-score of minus 2.13, that means it's more than 2 standard deviations away from the mean. And for 32,000, we're also more than 2 standard deviations away from the mean. We're 2.98 standard deviations below the mean. So those are both unusual values. Yes. Good job. So the lifespans of 3 randomly selected tires are 36,650 miles, 41,350 miles, and 39,000 miles. Now we're going to use the empirical rule to find the percentile that corresponds to each of those lifespans. Now keep in mind that the empirical rule told us that there were 68% of the data within 1 standard deviation of the mean, and so that's 34% on each side, both below and above the mean, that's within 1 standard deviation, and that there's 95% within 2 standard deviations. That's something we went over in class. So once we have figured out sort of what percent is in each of these regions, we can also, for this particular data, we know that the mean is 39,000, and the mean plus 1 standard deviation is 39,000 plus 2,350, which brings us up, when we go up 1 standard deviation, that brings us to 41,350. When we go up 2 standard deviations, that brings us to 43,700. When we go down 1 standard deviation from the mean, that brings us down to 36,650, and down 2 standard deviations brings us down to 34,300. So these are the cutoffs for these percentages. So looking at the lifespan of 36,650, that's 1 standard deviation below the mean. We know that there's a total of 13.5% plus 2.5%, which gives us, 16% down there below. So that means that this is the 16th percentile, because the percentile refers to the percentage of the data that's below. So enter there. Let's see, and then for 41,350, we have 34% here, plus 34% more. That gives us 68%. Plus another 13.5% down here, plus 2.5% down below, 2 standard deviations below. So that gives us a total of 84% down below. So this would be the 84th percentile. And the lifespan of 39,000 is the mean. We know that in a symmetric mound-shaped distribution, the mean is approximately equal to the median. That's the 50th percentile. So that should be our 50th percentile. And we can check our answer. Well done. I hope this helps. Thanks.